The definition of a random variable officially is a quantitative result from its experiment that is subject to random variability. Now, what that normally means is this: you can use any variable. Normally, you'll use x, and x will take on different values. It's a random variable. It's a discrete random variable is your data will be countable. Discrete means countable. For example, how many dinners you make per week, or how many insurance reports you filed. It's countable. So the number of values the random variable can assume is countable. Continuous random variables can assume any of the infinitely large number of points in an interval. So when they say an interval, think about the number line. And can you count all the numbers in between 1 and 2? Can you count all the numbers in there? No, you can't. There's 1.1, there's 1.11, 1.111. It's not countable. If it's not countable, it's continuous. If it is countable, it's discrete. So let's classify each of the following examples as either something that's countable or not countable. In other words, discrete or continuous. The highest wind speed of a hurricane, is that countable? No, because it might be 125 miles per hour, it might be 125.5, 125.55. Same as with the previous example. So this is continuous. The weight of baggage on an airplane, that's also continuous for the same reason. Might be 1,000 pounds, 1,000 pound, 1,000.1, 1,000.11. All right, number C, the number of pages in a statistics book, that's countable, otherwise known as discrete. The number of accidents occurring at a particular intersection, that's countable, that's discrete. Now, the reason we're talking about discrete distributions, the example we will use will be the binomial distribution. The example of a continuous distribution will be the normal distribution. Okay, a probability distribution for a discrete value will be a table or graph that provides the probability associated with each value of the random variable. Remember, the random variable is taking on different values. And we'll see expected value of x. That's the mean. Just a minute. All right, the requirements for your probability distribution for discrete variables. If you sum, all your probabilities are greater than or equal to 0. All probabilities, no matter what probabilities you're talking about, are greater than or equal to 0 for all x. And if you sum the probabilities in your particular probability distribution, they always sum to 1. Now I have some formulas for you. Expected value is the mean. And we write the expected value as either mu or we write it as e of x. And the way you calculate it, now remember, you're going to have a table. And your table is going to be made up of random values of x and the probability that each x occurs. So the way you're going to find the mean, you're going to sum up, we did that notation, sum, x times p of x. So you'll take the first x value times p of x, the next x value times p of x, and you'll be summing as you go. All right, the different formulas, some books use different notations, but it's always the x times p of x. Like I see it written like this: sum I equal 1 to n, x of I, that's your x value, and then the probability of x equals x of I. That one's more complicated, but I've also seen the very same formula written like that. Sigma squared, which is the variance, will be the sum. You're going to take the first x minus the mean that we found above, and we're going to square it, and then we're going to multiply it times the probability of that x value. Okay? Also, other ways I've seen the same formula written, more complicated. I equals 1 to n, x of I minus e of x, which is just another name for the mean, squared times the probability of x equal x of I. The way you find the standard deviation of x will be take the square root of the variance. And expected value can be interpreted several ways. It's the weighted average, the long run average or average return per dollar, fair value of a gamble, balance point for probability histogram, and then we've already said the mean is the expected value.